In this problem, we've been given a few points, and we're trying to find a fourth point, which makes the two lines parallel to each other. So let's just sketch this out. I have 2, 0, 5, and 8, maybe somewhere around here. And I have another point, 7 and 7. 7 over 7 up, maybe somewhere around here. So I have one line segment, A to B, which I'll do in green. This line segment here. And I need to find another point of D that makes this parallel. Well, first thing I want to probably do is find out the slope. So I want to find the slope of A to B. So it's going to be 8 minus 0, rise of 8, run of 3. So 5 minus 2 gives me my run of 3. And I can see that from my picture that, yeah, I've gone over 3 up 8. Now, to find another coordinate, really I can just use these changes. If this position C is at 7 and 7, if I just use this slope, if I go down 8 over 3, so I'm going to do that here. So I'm going to go down 8 to negative 1 over 3, and that's going to be at 4. So 4, negative 1 would be my coordinate. Using my rise and run, remember that this is equal to the change in y, the change in x. I can use those changes to move from point C to, we'll call that point D. That's just one possibility. We can use any ratio of 8 and 3 of change in x and change in y to be able to move that coordinate so that we have a point that is parallel, that would make a parallel line segment to the green slope. So there's an example where D could possibly be at 4, negative 1. We can go in the opposite direction. We can go 3 to the right, 8 up. That would be 10. So 7 plus 3. And 8 up would be 15. That would be another alternative. We'll call that D1, D2, and there's infinite D's that would work for this problem. In fact, we could even generalize this, and we'll see later how we can generalize something like this when we get into the other units. Here's a similar problem. We've been given a number of coordinates. So I've been given the coordinate A is 4, 0, 4. B is 3 over 8 up, so somewhere around here. And we have, so that's my A and B points. And I'm looking for this line segment. And I've been given a point at 9 over 8 up, so maybe somewhere over here. 9 over 8 up, so we'll call that line point C. Okay, so there's point C, and I'm asked to find a point D that is on the x-axis, because y equals 0. That point D there, where I have, it's going to intersect the x, I need the x-coordinate where it's going to intersect the x-axis. Okay, well, again, I would probably want to start, since we're talking about parallel lines, I probably want to start with finding the slope of AB. Okay, finding the slope of AB, we get 8 minus 4 over 3 minus 0. So we get a slope of 4 to 3. So there's my slope ratio, 4 to 3. Now, I can't just go 4 over 3, 4 down, 3 across, because this point C is at 9 and 8. Although the numbers do work out kind of nicely, and I could go maybe 8 down and 6 backwards. Okay, but I could also solve this a little bit more analytically and to say, well, if my slope ratio is 4 to 3, then I know my change here from C to D, the change in Y over the change in X. Well, I know the change in Y here is going to be plus 8. So I need to figure out, well, I'm going to go down 8 because I'm going to go down this way and across to get to the point A. So I'm going to say minus 8, and I need to know my ratio change of X. And I can solve for that algebraically. Just cross multiply that. I end up change in X is equal to negative 8 times 3 divided by 4. And that gives me my change in X is negative 6. So this ends up being negative 6 going across. Well, that would make the position A is equal to, I start at 9, and I'm going to minus 6. Okay, that's going to be equal to 3. I could do this a little bit more analytic. I could put that right into the equation if I like, but there's my change in X. Okay, is I'm going to add that to original X coordinate, and I'm going to get to the position that I want. So A is equal to 3. So in this case, the position A is at X equals 3.